x to the 4/5. Would you know another way to write that? If you really understand what the 4/5 power means, you should know another way to write it. I think this will be one of the harder things on the final, is remembering weird exponents. Did you know that that meant x, but the 5th root of it, and then to the 4th power? Raise your hand if you had that one right. All right, that's a lot of you. Good. How about if I had a to the -2nd over a to the 3rd? What would that be the same as? Don't say it. Write it. The way I like to think this through is these a's are not happy where they are, so you can move them to the other side of the fraction bar. This is not a mathematical way to do it. I'll tell you that way in a second, but I like to think of it that way. That would leave a 1 left on top, and then these ones that were unhappy up here become happy, as in positive exponent, on the bottom. And then you have to know that that kind would combine together, you don't multiply that kind, you add that kind, because this is like AA times A, and of course you're going to look at that and go, there's 5 A's there, a to the 5th. This is an acceptable answer, but I want you to also know that's the same as a to the -5. Either one of those are correct answers. Raise your hand if you knew that. Okay, good. Any questions about that? All right. Next topic. What if I go backwards? What if I say, here's an x, 3rd root, but it's squared. Oh, but by the way, I want 1 over all that. Can you write that as x to a fraction power? You may not remember fraction powers being there that much, but they are because they're in the middle of logs problems. I hope you caught yourself and didn't write 3 over 2, because it's the other way around. It's 2 over 3. But something should feel wrong about that because of that 1 over. That 1 over here isn't been accounted for. That's a negative power. Who had negative 2/3 power? Okay, good. Doing better than I thought on that. And here's another topic that I think might get you. Do you remember that deal where certain matrices can multiply by certain other matrices? I'd like you to write down what's that rule for the R times C and the R times C here, the rows by column. What's that rule about whether or not they can multiply? If you forgot, it's okay, I'll tell you in a minute. But if you forgot, you better write it down so you can review that for the test. There's something to do with the rows and the columns in the one matching up with the other. So I'm going to give you one here. If I said 1, 2, 3, 4, 5, 6, you should know what that is in rows and columns. And if I said this one's a 2, 1, 1, 1 matrix, you should know what that is in rows and columns. And then you should know whether or not this one can multiply. And there's a follow-up. If it can multiply, then what will it be? All right, Jack, what is this in rows and columns? All right, so you're saying there's 3 rows and 2 columns, and you are correct. And this one's a 2 by 2. What's that rule? Tate, do you remember the rule?
The 2 and the 3 by 2 and the first 2 and the 2 by 2 have to equal the same.
These?
Yeah.
Those, what about them?
They have to equal the same.
They have to match, I agree. And they do match, so what does that mean? They can be multiplied, and the answer will be a
3 by 2?
3 by 2. It's the outside ones that tell you what you will get. A lot of kids know the inside ones tell you that they match, but a lot of people think that then the answer is a 2 by 2. No, the answer will be the outside ones, so 3 by 2. All right, let's imagine a world where you had to make the answer. I would like you to tell me what the very last number in it would be. So make a little eggs. I personally, if it's a 3 by 2, I know that looks like this. I would just make my eggs in here like this to remind myself those are the numbers I need. And if you know how to do this, it should be easy peasy to figure out that last number. Now you might be thinking, well, I'll just use my calculator for this, because you will have a calculator. The problem is that we would throw a letter in it, and that foils the calculator if there's a variable in it. I'm not going to put one in there right now, but that's how we would keep you from just using the calc. This is row 3, column 2. You got to know its address. Then you go over here and you go, row 3, that's this row. Column 2, that's that column. And then you go the 5 times the 1 and the 6 times the 1, and you add them. 5 times 1 plus 6 times 1, which is 11. Who had an 11 there before I said it? Okay, good. Any questions? Reminders? Okay, so that's about multiplying matrices. Here's another kind. I'm not wasting your time. I looked through the final to try to figure out what should I, like, remind these guys to practice. That is a math problem. A is something. Probably a matrix. You got to figure out what matrix A would be. So solve it like you solve an equation. You want to get A alone. So you think to yourself, what should I do to get the A alone? When you're done with this one, compare your answer with the kid next to you. All right, so here we go. I would have started by adding this matrix 2, 1, 0 to both sides. You do the opposite, right? And this one's a negative matrix, so we add it. And that'll cancel each other out. And so then this is 2a equals, 10 plus 2 is the 12, 13, 14. And then how do you get this 2 off of here? It's a trick question. You're going to say divide by 2. Technically, matrices can't be divided. But you can multiply both sides by 1/2. And that will cancel that. And multiplying by 1/2, you can do. And so that means your final answer is 6, 13 over 2, which is half of 13. And then 14 divided by 2 is 7. Or 1/2 times 14 is 7. There's your answer. 13 halves, which would be like 6.5, and 7. All right. There's one more kind with matrices that I thought I would remind you about today, and that goes like this. Don't copy this down, but try to figure out what the trick is. This is an equation. You can make it into a matrix. This is an equation. You can add that to the matrix. And this is part of the matrix. And you can put that all into one big matrix problem, which you could then solve with the calculator. But you've got to be able to make it into a matrix problem first. And there's some trick element to this. First of all, you got to know how the matrix looks. We don't tell you. Now, I'll tell you, for this problem, you'll have one big matrix. Then you'll have a matrix that has all the variables in it. And then you'll have another little matrix like that. That's the matrix style we want. But there's a trick. I'm going to pause for a second while you try to make this matrix. You don't have to even solve it right now. I'll remind you how to solve it later, but just make the matrix. All right. How many of you caught that This X should have been over there because it just doesn't have a Z. So these were out of alignment. You have to look for that. There was clearly something missing, but it wasn't an X. The thing that was missing is it didn't have a Z there. So this was a 1 and a -1, and these were obviously numbers. Oh wait, there's a 1 there. And then this was a 4 here, and a 5 here, and a 0 there. Because it had an X and a Y, but it didn't have a Z. So the numbers go 1, 2, -1, 2, 3, -1, 4, 5, 0. And then X, Y, Z. Because of alphabetical? No, because that's the order that we have them in. X, Y, Z is in order alphabetically, so this has to be in order alphabetically. If these had been in a different order, then we would have made this in a different order. Okay, and then the last numbers are as simple as 0, 8, and 10. I would always call this matrix A, and I would call this matrix B, and I would put those into my calculator under the matrix button. And then I would get this A off of here. And how do I do that? By multiplying by A to the -1, and you have to do that on the left because matrices care if it's left or right. If you switch them around, the answer changes. So this will take out this, and the inverse can be done on the calculator, and this just cancels, and that's where you'd get your final answer. It was inverse A times B. Just a quick reminder of how that kind of works. All right, and that is a short review time. And now your job is to work on the review and ask me questions. I want you to take out that review packet that I gave you, have it on your desk. If you're done, even better. I can see that you're completely done, but take that out now.